15.2, 15.3, scientific notation. I can use scientific notation to represent very large and very small numbers. So these have to do with exponents a little bit, so that's why it's with our exponent rules. So when we are changing large numbers or quantities to scientific notation, when the number is greater than or equal to 10, we use a positive exponent. So you can see we had the 84,000. And we moved our decimal 1, 2, 3, 4 times so that it's in between a number less than 10 but greater than 1. And then we made our exponent 4 because, and we times it by 10 because it's a base of 10, right? Our number system is bases of 10, 10, 100, 1,000. So times 10 to the 4th is that place value there at 10,000, right? So, and then the decimal point moves 4 places to the left. So let's make 6,400 a scientific notation. The decimal's in the very back of it. So it's here. We always move it to the left because I'm trying to make it into a number less than 10. So I would go 1, 2, 3. Now I have 6.4. That is less than 10. I times it by 10 to however many times I moved it, 1, 2, 3. That's scientific notation. So let's look at number 4. I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11. So I get 5.7 times 10 to the 11th. It is not just how many zeros there are. That is not the rule. I need my number to be between 10, less than 10, and 1 or bigger. Okay, it has to be less than 10. So maybe pause here, see if you can do number 5, and you can do it on your own. All right, you should have gotten 9.461 times 10. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so then when we need to take it back to standard notation, we take our decimal and move it however many times the exponent says. So it says 9, so I'm going to go 1, 2, 3, but then I fill all the other spaces with zeros. 4, 5, 6, 7, 8, 9. So 7, 0, 3, 4, and then I have 1, 2, 3, 4, 5, 6 blanks. So I'm going to go 1, 2, 3, 4, 5, 6. And then I can put my commas in, and that's my number. Really, really big. So same thing. Here's my decimal. Here's my exponent. I move it this way now, opposite direction. So standard rotation, we go to the right. So we go 1, 2, 3, 4, 5, 2, 3, 6, and I have 1, 2, 3 blanks. Okay, pause, try number 10. Try number 10, where's your decimal? So we should have just gotten 5 with 6 zeros because the decimal's here. And the only thing I have are blanks. So when you move it over, all you have are blanks because there were no numbers after my 5. So there it is, 5 million. So that was changing numbers that are really, really large using scientific notation. What we're going to do now is take numbers that are really, really small and change them to scientific notation. It's exactly like what we just did, except we're going to go the opposite direction. We're going to go to the right. And we're going to use a negative exponent. Okay, that's because negative exponents, if you remember, it makes it into its reciprocal. It makes it like a fraction, and fractions are always smaller than 1. They're really small things, right? So same idea, though. We want it to be between 1 and 10. Okay, and so we're going to move it to the right. 1, 2, 3, 4, 5, and now I have 8.29 times 10 to the negative 5. Okay, if I move it to the right into scientific notation, it has to be negative. These are really small numbers. Okay, let's do the next one. So 1, 2, 3, 4, 5, 6, 7, 3.02. So I stopped there because if I went one more, it'd be 30. 30 is bigger than 10. I don't want it like that. I want it to be less than 10. Times 10 to the negative. I forgot how many times we moved. 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. Yeah. That's supposed to be a multiplication sign, but that's okay. All right, pause here. See if you can do number 6. Check it. Make sure you can turn that into scientific notation. So we should have gotten 7 times 10 to the negative 1, 2, 3, 4, 5, 6. And yes, you have to move all the way behind the 7. It can't stop in front of the 7. That's not science. We need it to be bigger than 1. It has to be between that 1 and 10 range. Okay, so these last 3 are scientific notation to standard form, but now when we have a negative exponent, we need to move it the opposite direction. So negative exponent to standard form, we are going to move it to the left. So we're going to make it back into its really tiny number. We're going to move to the left. So it says negative 6. So I'm going to go 1, 2, 3, 4, 5, 6. All the spaces get filled with zeros. So I have 1, 2, 3, 4, 5 blanks. I always like to put a 0 and then a decimal. I would suggest you do it too. And then we put all the numbers back. 1, 0, 4, 5. So you can see it's a really small number. Okay, so next one, negative 5. So we're going to go 1, 2, 3, 4, 5, running into my other problem. So here's my decimal, 1, 2, 3, 4, 9, 9. Blanks, 1, 2, 3, 4. Okay, pause. Try this one. Remember from our last one where the decimal was, so let's see if you can do this one. So decimal, remember, was behind the 1. We go 1, 2. So you should only have one decimal, and there it is to the 10th. Or to the 100th. There it is, 100th. All right, so things to remember. If we're going to go standard form large number to scientific notation, move to the left. That's what these, oh yeah, standard form, large number, move to the left. Standard form, small number to scientific notation, move to the right. This one will be a positive exponent. This one will be a negative exponent. So scientific notation with positive exponent to standard form, move to the right. And then scientific notation with negative exponent. And yes, I know I spelled that wrong. To standard form, move to the left. All right, both of these are standard form to scientific. So you're going to want to use these two. This is a really small number. This is a really large number. And those are your independent practices. Until next time.